Take a look here at coming up with the missing angle. So we're going to look at two examples in this case here. The first one is going to be finding this angle right up here. And the second one is going to be finding angle X. So that would be this one right here. To find this one here, the first thing that we need to do is, and this is a case in every single question, we need to label our sides with opposite, adjacent, and hypotenuse. The long side here, as always, is going to be our hypotenuse. So we'll label that, we'll put that in, that'll be the hypotenuse. And then based on this angle here, the leg that is beside the angle is going to be our adjacent side. So that'll be our 8-meter side. So we'll put that in over here. And then the other side, so the side that we are not using it, or we have not labeled so far, is as usual going to be our opposite side. So it doesn't matter what kind of question we're looking at, we're going to be labeling our sides right off the bat. That's the first thing that we always do. Now the second thing that we're going to do is we're going to determine which equation do we need. Okay? And that equation is going to differ depending on the what information we have. These questions right here are only dealing with tangent ratio. The next, or as we move farther along, we're going to deal with other ratios as well, and we'll get into that shortly. But we know that tan theta is equal to opposite over adjacent. Okay, this is our equation. Every single time we got to find our equation. In this case here, we're going to be using our tan equation, or our tan formula, which is also our tan ratio. All right, so now that we have that, we're going to plug in the values that we have to find theta. And because we're trying to find theta, it's going to be tan -1 of opposite, which is 14 meters, over adjacent, which is 8 meters. Shut off the brackets. We'll get rid of the other wording. There we go. Okay, so we're going to now, I don't need a bracket inside. I'm not sure why there's one. I probably put one in there. Okay. There we go. Okay, so now we're going to do this on our calculators, and we're going to try to figure out what is theta. So, couple different ways of doing it, and again, I'm going to show you in class as well when you are here. But to find our answer, I'm going to pull it up on this calculator, and I'm going to make sure that I'm in degrees. So that's always important. I'm going to do 14 divided by 8 equals, okay, going to come up with a decimal. In this case here, it's a nice one. And now we're going to do inverse tan of the answer, and the answer is right there. Okay. On some of your calculators, you'll be able to do inverse tan, and it'll automatically pop up. But now we do inverse tan, and we come up with our answer of 60.26 degrees. Okay, 60.26 degrees. Oops, sorry about that. And so our angle is 60.26 degrees. And we could also just round that to 60 degrees as well, and that would be our final answer. Now you'll notice here that these triangles I try to do somewhat to scale. So in other words, you'll see this is a bigger angle, so it should be a bigger degree. If the opposite side is longer than the adjacent, our angle is going to be greater than 45. If our adjacent side is bigger than our opposite, then the angle will be less than 45. And so that's what we're going to take a look at here in this second example. So let's determine the measure of angle X in here. Angle X is this one right here. And so I'm just going to draw that in. And let's do it with blue. Okay, there's the angle that I'm going to do, and this is theta. Okay, there we go. There's angle theta. We consider this angle theta as well. Okay, it's our unknown. Yeah, unknown angle, we'll call it theta. So here's theta. We're trying to find angle X. That means that this is the hypotenuse. Okay, that means this is, again, the leg right beside is going to be our adjacent. And our other one is the opposite side. Now again, every single triangle label, okay, every single one. Maybe your writing will be neater than this, maybe it won't be quite as neat as this, that's okay. Every single time we label our three sides, hypotenuse, opposite, and adjacent, every single time. Now again, we have the adjacent side and we have the opposite side, which means that we're going to be using our tan ratio. So I'm just going to have to give it a second here for it to load up, but we're going to put in our tan ratio here. Okay, again, it's the exact same thing. So it's tan theta is equal to opposite over adjacent. There we go. Okay. We know our opposite and our adjacent. We have our opposite is 82 yards, our adjacent is 62 yards. Okay, again, smaller adjacent than opposite, meaning that it's going to be a bigger than 45 degrees. Theta is equal to tan negative 1 of 82 yards over 62 yards. Now again, big numbers doesn't really mean anything. It just means we've got to type in bigger numbers into our calculators. Right. But the angle is still going to be, this one looks like it'll probably be, if we can just guess a little bit, probably be around 60 degrees as well. There's a good chance. And sometimes if we just do a little judgment call, we can kind of figure that out while we go. So 82 divided by 62. And we come up with decimal. Right there, 1.32. So it might be actually a little less than 60, we'll see. Inverse tan, and I have to put an answer, you may not have to. Well, again, we'll talk about that in class. 52.9 degrees or 91 degrees. We're going to round to 53 degrees. I'm just going to call this one 53 degrees. 53 degrees. Again, often just do it to the nearest degree. Sometimes we'll ask you to do 2 decimal places, but for the most part, we'll round it to the nearest degree. All right, so important couple steps. Label all three sides. Hypotenuse, adjacent, opposite. Adjacent is always beside the angle, opposite is not. Okay, hypotenuse is our longest side. Then, in this case here, we're using tan. All you're going to do is plug in your values for opposite and adjacent, do inverse tan, and then that will give you your answer.